morning, good afternoon, good evening, wherever you are in this world. Welcome to our webinar. We are very excited to be on part 3 of our introduction to networking. So we'll just throw our PowerPoint up here. Those of you who have been here before know our two amazing presenters. We have Robert Lastinger from Distech Controls and Dave Cousins here from Optigo Network. We're very, very excited to have them back today to tell us more about networking. As you may or may not know, this is a 5-part series. So we started doing our first webinar and realized one was way too little time to cover everything. So today we're on our 3rd. We will have our 4th one in May. So that's the transport and application layer. We'll be talking about UCP, TCP, backnet, different protocols. So make sure you register for that. The link is on the top of this page, and we'll also put it into the chat box. And finally, in June, at the end of June, we will be having a webinar on designing a network. So that's going to be a 2-hour webinar. We are going to live set up an Optigo and a Distech network together. If you don't use Optigo and Distech, it's okay. It will also be relevant to you. So definitely make sure you tune into that because it's going to be very exciting. And I believe that's it for me. So without further ado, I'm going to pass it over to Robert and Dave. If you have questions throughout the webinar, feel free to pop them into the questions box. I will be taking a look at them and asking them if it's appropriate throughout the webinar, or we'll probably hold most of them for the end because we do have a lot to cover. Thanks so much. Rob and Dave, take it away.
Good morning, everyone. Yeah, there's a lot to talk about today. The agenda basically is we're going over a lot of things on the layer 3 internet protocols, and we'll go through this list, so I won't read it out loud. Make sure you can download the handout so it's got more information than the slides, and we'll jump right into the internet section. So building on the past webinar that we've done, we talked about the physical connections and the network access layer, which would be layer 1 and layer 2, if you're familiar with the networking, the OSI layering. Today we're going up a layer to layer 3, and this is where all of our systems talk to each other across the internet and across connected networks. A couple of key things that we need to do here. One is you can see the little blue box there. You don't need to know all the details here, but at the IP level or internet level, we create IP packets. The key things to note is you've got a destination address, which is an IP address, and a source IP address. And all the routers and all the networking equipment out there use that to actually route your packet to its destination. Some of the key protocols we're going to use here is IP. That's the standard across the board. ICMP, which you'll be familiar as ping. So when you're pinging to check and see if you have connection with the machine. ARP, which is address resolution protocol, and there's a reverse as well, and that's for translating IP addresses back and forth. And we'll talk about IPv4, which is your standard, as you see on here, is an IP address 192.168.206.32. That's your standard IPv4 IP address. There's also IPv6, which we won't talk about necessarily today. Maybe we'll save that for a future talk. It's coming, but it's not as relevant right now. So going a little deeper into the concept of IP addressing, every device in a network has an IP address, anything that is routable. What you see here on the left is a switch, and we're giving that an IP address 192.168.12.1. And then we have a switch with a bunch of devices connected to it, and each one of them gets their own IP address. And then packets can be routed to the very specific destination. We, in our case, with our switches, for example, they actually have an IP address as well. Because we can do management over IP. Down at the bottom right, you can see we talked about a network mask. So Robert's going to go into a little more detail on subnetting. This basically says this group of IP addresses are they're connected. They're a group, and a default gateway. And again, I'll go into a little bit more detail later on in the presentation. But anything that any object in the network that doesn't know how to route something itself will have a default gateway. And so it'll hand that packet over to the default gateway, and the default gateway will know how to route it. And of course, if it doesn't, it'll hand it off to its default gateway, and so forth until it finds a route to get to its destination. Some key IP addresses that you want to know about. So anything in the 127 dot something is considered a loopback or a local host. What that really means is you're referencing your own machine. So 127.0.0.1 is considered localhost, so I'm pointing to myself. So we will never assign these addresses as the address of a device in the network. Likewise, so private networks, there's several ranges. These are the main three that are used. So 10.0.0.0/8, and talk briefly about the /8, but and Robert's going to go into the details on how to figure this out. But that's basically the size. So each of the 4 digits has 8 bits in it, and so a /8 is the first one. So anything but 10 dot something is considered part of that network. So the 10 dot somethings are private. The 192.168 dot something is private. You can see it's /16. And then 172.16.0.0/12, those are all private as well. And so what that means is that they're reserved for people to use internally within a network that's not connected out to the internet. And we'll talk about NATing later on as well, which is a way to translate between those two things.
David, if I could jump in real quick, just point out one thing. One of the most common mistakes we see with private networks is with the 172 range. It's, you see there it's 172.16.0.0/12, and frequently what we'll see is somebody will accidentally say 172.20 or 172.30 or something like that, thinking that that's private, when in fact it's not. So be very careful if you use the 172 range to make sure that you keep it. You don't go with .17 or .15. It needs to be .16. I only mention it because we see it quite a bit, and it's an easy mistake to make. So that one, keep note of that one.
Yeah, definitely. I see 90% of private networks they use the 10 or the 192.168. Yeah. Great. And then anything on the 0.x.x.x is reserved. Those are network source addresses, so you'll never ever see that. And anything between the 224.0.0 all the way up to 255, those are all reserved by the standards body, and nobody uses them as well. And you may note there it only goes up to 255.255.255.254. Well, there's one more IP address after that, so you can have a .255 at the end. And that's specifically for limited broadcast. All right, so that's IP addressing. We'll go in a little more detail about the subnetting and the slashes a little later. We have a calculator and a demo for how to do that. What I want to bring, so everybody that saw the last webinar, on a layer 1, layer 2 physical connections, we built up this little network. And so what you can see there, in the green device is a network controller or a head switch. The devices with the blue faceplates are all switches. We've got lights and valve controllers and various devices connected on the end there. So we just kind of created a little network and talked about all the ways we can connect those up. Today we're gonna use the same diagram, and we're gonna put all the layer 3 stuff on top of this, so we can show you where it actually exists within the network. So as we go through each section, we'll add to this. Okay, so I'll hand it over to Robert to start talking about how we assign IP addresses.
All right. This one's probably familiar to a lot of you, but here we show the IP address, the subnet mask, the gateway, primary DNS, and secondary DNS. Most of you at this point are probably somewhat familiar with these on your own machines or on controllers that you've maybe programmed. The IP address is obviously how we resolve the MAC address to the device. So that's pretty straightforward. The subnet mask is kind of a grouping where how many controllers are going to be in that group of controllers? How many IP addresses or hosts can you have in a group that can communicate directly to one another without routing? Gateway is how you route out. So if you need to get to another subnet or another group of controllers or out to the internet, that's going to be the address of the controller, and that will most likely be on your network, in the same subnet. Primary DNS, domain name system is how we resolve host names. So if you need to get to something, whether it's internal or external, you're going to need to resolve the host name if that's how you are addressing it. So say if you're trying to get to google.com or any other website that you might frequent, you're going to need to have a DNS server to do that, unless you want to type in the IP address of the server manually. So then that's not usually the case. These can also be used internally, and we're not going to really cover that too much today, but we may later, where you can use host names to resolve controllers and other systems even inside your own network, and your DNS server will handle that for you. So if instead of, say, always routing to a controller at 192.168.206.32, you might instead say this is going to be controller1. Whatever domain. And that way, in the future, when you change the IP address of the controller, nobody needs to know that, because the host name would resolve that for them. So if you program with that or use the host name to route traffic, you don't have to worry about controllers being readdressed later. So that's a concept we're probably going to cover later. But for the networks, for what we're talking about today, DNS won't necessarily be a big deal. We're mostly concerned with gateway, subnet mask, and IP address today, although almost all of you are going to have a DNS entry for anything we do today. It's very hard to have a network without, if you want to route out to the internet to get weather, time updates, all of these things, you're going to need a DNS.
And just to add to this, you can see this DHCP is a secondary way of assigning, but you can actually just type in the IP address here and assign it statically, and that's an option, but that's full of potential human error. And we'll move on to the next section here, which is about DHCP.
Yep. So perfect. This is what we hope most of you are using if you're doing a controls network. I know typically in the past, everybody's used static IPs because they're easy. You pick an IP address, you assign it, you know where it is, so there's no guesswork, and then off you go. And that worked very well when we had systems with very few hosts, very few controllers or devices that had IP addresses. Now we're getting into systems where we have IP addresses at a light bulb, at a light switch. We have IP addresses everywhere now. So it's now we're getting systems where there's thousands of IPs, and doing static assignment isn't going to work. It'd be very difficult to maintain that. So a DHCP server, DHCP in general, allows us to put a controller on the network, and it requests an IP address from the DHCP server. And that can be in the form of a broadcast or request. Here we go with an IP lease request, and then an IP lease offer, IP lease selection, IP lease acknowledgement. And so those are technical terms, but really what's happening is you put your controller on the network, and it basically announces that it wants an IP address, and then DHCP server responds, or broadcaster responds. And then the controller will take the IP and acknowledge it, and then the DHCP server registers that, and now they agree that we both have this IP for this period of time. There will be a time, and at the end of that time period, the controller will request again. And typically, most times it'll get the same IP on most systems, but that's not always the case, depending on how the server was set up, or if something was rebooted, or if something was offline for a period of time, maybe its address got handed out somewhere else. So we're going to go in depth on this, and we're going to demonstrate this in one of the demos, but it's important to note that DHCP is probably, on all of the systems going forward, you're probably going to want to leverage that. It's a powerful tool, and we can use dynamic assignment, we can use reserved leases to ensure that your controller gets the same IP address every single time. So here we talk about lease reservations are the preferred over dynamic leases in controls networks. And this is because this is kind of the best of both worlds. If you are accustomed to having static IP addresses before, well, a lease reservation gives you that same ability. You can define it, so when you get your controller or you get your device, you can look at the MAC address, which is typically on the device itself, or once you put it on the network, you can look at the DHCP server and see what its address is, its MAC address, and then you can assign it an IP address that will be handed to it every time it requests a new IP when its lease is up. So that way, it's always at the same location. So you're still getting the benefits of having what you did before with a static address. So if you know your server is at 192.168.0.50, it can always be there, but that can still be a dynamic address with using DHCP. And the benefit of that is later, if you have thousands of controllers and you need to reassign IP ranges, maybe the company you're working for was sold, or maybe the IT department is updating, and you need to reassign thousands of IP addresses. Well, with a DHCP server, you can do that very quickly in a few minutes. And then when the leases all expire, the controllers will all get their new addresses. Whereas if you have thousands of controllers with static IPs and you need to go back and change them, you're going to have to spend a lot of time on a job doing it. I've been there, and I've had to spend 2 weeks doing that to thousands of controllers. I don't recommend it. It's not as much fun as it sounds like. So really what we want to stress here is that DHCP is really what we should be using on our networks, especially managed networks. And then if you're going to be using DHCP, it's really smart to go with reserved leases so that you know what address the controller has. It'd be very difficult to set up a backnet network or any kind of IP network with servers if you don't know what address they're going to have every time they get a lease. And it's easy to walk away because initially you may think it always gets the same address, but if it were to go offline for a period of time and someone plugs their laptop in, all of a sudden it won't get that same address unless it's reserved. So I think that probably covers that one. Yep. Okay, this one's pretty straightforward, yeah.
Yeah, and basically what we're looking at here, again, we want to overlay this on top of our network. There's two possible ways we can create a DHCP server. One, we can buy a standalone DHCP server and just plug it into our network anywhere. Again, as Robert was mentioning, there's a broadcast, please give me a DHCP, an IP address, sorry, and the DHCP server can respond to that from anywhere in the network. However, I think most applications will have an integrated DHCP server in the router/gateway. If you look at, for example, your home system, if you look at most routers that are out there have the capability of doing IP address management. So they have a DHCP server integrated into them. So that would be the two preferred methods of doing this. Just one other note here, you can have multiple DHCP servers on a network, and they can both respond to a request. And you can get two offers to have different IP addresses, but the client just has to pick one.
We're going to be showing a demo here to discuss some stuff. And on the bottom right of the screen you see there, you'll see two controllers and an ONS C40I, a switch. Those are the two pieces of equipment, or three pieces of equipment, that we're going to be demonstrating. So if you're looking at this diagram wondering what we're showing you, it's the two controllers, the VAV controllers, and the switch in the bottom right of your screen. Okay, so here we're kind of starting the demo here, and if you'll watch along, you'll see here we're going to open ExpressNet utility, and this is just a utility we use to discover the controllers on the network. And so that'll start, and we'll just see those controllers pop in here shortly. And here we're just authenticating to the controller so that we can discover them. Okay, we have two controllers which are both on the same subnet currently. And we'll bring those up in the web browser to demonstrate them to you. Okay, this is the interface for the router which assigned the DHCP addresses to the controllers. We're sitting at the interface for the router, and we're going to go into the services of the router, and we're going to look at DHCP. And this router has a single range from 100 to 150 with a subnet mask of 255.255.255.0. So the controllers were individually given the addresses 101 and 103 from the DHCP server, and those were the MAC addresses assigned to them. And you can see here they match when we discovered them. So now we're going to log into the controllers individually. And we'll take a look at the settings there. Here's the second controller. And we'll bring that one up while the first one loads so we can discuss it. Okay, here under network, you can see the controllers were assigned. We just simply checked the DHCP in this case so that they were automatically handed their addresses. And you can see the MAC address here of the controller and that it was assigned DHCP. So now we're going to reserve an address for one of the controllers because we don't want to leave them this way. So we're going to show here, we're going to create an address reservation and assign it to one of the VAV controllers. And there's it'll pop up here in just 1 second. There we go, copied it. And here, under the DHCP server, we'll add our reserved address or our static mapping. There's the MAC address. And now we'll add the IP address that we want. Now, it's worth noting when you are creating reserved leases, usually you want to give it an address that is outside of the dynamic range. So if your range is, in this case, was 100 to 150, it's advisable to give it a reserved address that sits outside of that range because you don't want to have a conflict where your DHCP server hands out an address to a new controller that should be reserved. So a lot of routers will protect against that, but it's not worth risking it. So typically we advise have a small DHCP range, like 100 to 120 or 20 to 40, whatever the case may be. And then for your reserved addresses, don't put those in the range. So they should be separate ranges, really. And now we're going to rediscover the devices since we've reserved that DHCP address. And in the background, I unplugged the controllers and replugged them in so that they would repull their addresses from the server. Because obviously we don't want to wait for the lease to expire for the purpose of the demonstration. So when we log back in here, we should see on the page, we should see that the controller has got the reserved address that we wanted it to have. And here it does. At 161. So this part is pretty straightforward, and I know most people, we cover this because it helps with some of the stuff we're going to later in the presentation, but it's pretty straightforward and pretty easy, but really the important things to remember here are to make sure you keep your ranges separate and to assign those early on so that it's really easy to manage your network. But on a big network, we want to stress that doing static addressing is really not a good idea. And here we're going to return, we're going to remove the, we're going to add the host name here to the DHCP address. And this is, we didn't really go into this too much, but when you add the host name to the DHCP server, and in this case, the router is also acting as your DNS server, you can now resolve that host name on the network if you don't want to have to use an IP address. So I could use ECY-100 or ECY-VAV or ECY-room, whatever I wanted. And then I no longer need to use the IP address to resolve it. I can just use the host name. So we've combined there the host name and a reserved lease is kind of a best case scenario for managing your network.
All right, so that's DHCP and IP address assignment in general. The other kind of big picture piece of layer 3 is IP routing. So we talked briefly about this at the beginning. Basically, every device can route, but there are actually routers that are out there that's their job. So what they do is sit in the middle of the network and take traffic in, and they know where to send it, whether it be within the local network or out to another router, out to the internet in general. They know how to do that because they have routing tables that they build up within the router. Each vendor has to some extent their own way of building those tables, and it's based on feedback it gets from the network in terms of what's the best path out to the destination. The example we have here shows a router in the middle, and then basically if we wanted, let's say 10.10.88.100 was our PC, and we wanted to get to a website that was 192.168.11.20 so we could view it. But our PC doesn't know where that is. What it does know is it has a default gateway, which is 10.10.0.254. And it knows to send any packets out on that interface that are unknown destinations. So that basically on your left will mean that your PC is sending out that packet to the router. And then that router is going to do a lookup on its routing table, and it will see my destination is 192.168.11.20, and it has a routing table entry that says, if you look on your upper right side, anything in the 192.168.11.1/24, so that would be the last variable in the last of the 4 numbers. Anything that's in that range, send it out on that interface. So the router does that, and then it gets into the network where that web server is, and it reaches its destination. So the router, all it's doing is looking at a packet's destination and figuring out the best path for that to go. One key thing you want to note is that routers are routing things to specific destinations, and they don't generally route broadcast traffic, which is a problem for BACnet, which is why we have BBMDs, because they turn broadcast traffic into unicast. So it looks like it's going to a specific destination, which is another BBMD. This is an example of a routing table on a PC. So there's actually built-in router on your laptop or your PC or basically anything, but they're very simplified. You can see on the top section, it just shows the interfaces, and this laptop has a Wi-Fi connection. It has a Bluetooth and so forth. So that's not the important bit. The important bit is the routing table on the bottom. So for example, that very first entry in it, which basically says any IP address I don't know, and that's what the 0.0.0.0 means, send it out on my default gateway, which is 10.24.0.1. And essentially anything that doesn't fit into any of these other entries in the table is sent out on that interface. So the same thing happens within a router. There's just many more entries within it, depending on how many interfaces it has. You can also look down that list, let's say the third or fourth ones. That's a specific IP address. So for some reason, this particular device knows how to route directly to those, and the reason why is because that's its IP address. So it's actually anything that it routes back to itself, it would send to 10.25.188.111. So every router has some form of this, which basically learns how to send traffic out on the various interfaces. The metric column on the far side is an interesting one. Basically, there's going to be multiple ways of routing traffic to its destination, just the nature of the way the internet is set up. There's always multiple ways of getting from point A to point B. The metric is usually, the lower the number is the better, which means it's, and again, the formula is kind of magic here as well, but it continuously is looking at that route and seeing how fast the traffic gets to the destination, whether it's successful or not, and it calculates a metric. So if there's multiple ways of routing a piece of a packet, it will pick the one that has the best metric and it will send it out on that interface. So that's routing table. It's fairly straightforward, but there's a lot of kind of magic in how the routers figure out which how to route traffic out on different interfaces and which one's the best. So what you'll notice here on the left. So again, let's say this network is in our building. We have a router /gateway that allows us access out to the internet in the center left side of the screen. There's a couple of different possibilities here. One, it could be used as a gateway to send to the internet. So any traffic that it doesn't know how to route to sends it out to the internet. And that's how it would get to a second campus, maybe in another city, as part of a wide area network. Although it might also be wired directly to another router in a building right next door. So you might have a series of buildings connected together, each with their own router, or in this case, building 2 and building 3 are connected to a single router. So the first router gateway, as you're directing traffic out of our building, it'll have a routing table entry that says, if the IP address is in the range of building 2 or building 3, send it to the router on the bottom left. If it's anything else, send it to out to the router, out to the internet, and it'll be directed to the second campus. So that's an example on how that would work. We actually have Robert's got an example here on how to set that up, also using VLANs, which we talked about in the last webinar.
Yeah, I think this is the demo for the VLANs, correct?
Yeah.
Yeah. So here we're showing we have 3 network connections on this computer, and each one is sitting on a separate VLAN we created just for this demonstration purpose. So the reason I'm showing you these here is so that you can see that that's how the machine, the computer, the Windows machine is talking to each of those VLANs. We simply put them on each network connection. So that simplifies it for the demonstration purposes. You probably wouldn't do this to an actual server, maybe, depending on how your network is set up, but it allows us to break connections and make them without losing communication to each device. So,
yeah, and it's acting as a.
Go ahead.
I was just saying, and it was acting as a router. Yeah,
and so here we're gonna bring up a couple of the same controllers we looked at before when we were doing DHCP. So we're gonna look at, this is the standalone interface for the Optigo switch, the ONS C401, and we're gonna show here under Layer 2 switching, the VLANs that we have in place for these devices to sit on. So we have VLAN 100, VLAN 200, and VLAN 4093 are the three we're going to be concerned about for this demonstration purposes. And those VLAN 4093 is what allows me to talk to the switch itself on port 4, and then the other two VLANs are what we're going to use to route to the controllers. And we're going to create rules and break them to see how those two controllers can talk to each other over VLANs. So here we show at the router, we show the same VLANs because we need them to be there to have the rules. So here we show VLAN 100, VLAN 200, and VLAN 4093. And here they are again under the VLAN section for interfaces. And here we're going to show the rules associated with those VLANs. And in this, we're not really concentrating on creating the VLANs here. We really want to showcase the purpose behind the VLANs, which is segregating traffic, preventing broadcast traffic or other types of traffic from going from one VLAN to another. So for whatever your reason for needing them, we want to show here, we have rules here, the ones that are highlighted, to prevent traffic from jumping VLANs. We don't want, in this instance, we want them to be isolated. So we created rules in the firewall to prevent them from talking to one another. And here's where the ports were assigned on the Optigo switch. And here's where we decide whether we want tagged or untagged ports. And we may want to look a little bit further at this one, Dave. So here, this is worth discussing real quick because this is kind of where the magic happens for VLANs. We have the ones you need to pay attention to here. We have excluded, tagged, and untagged. So we're going to cover those more in depth later when we show how to create VLANs. But really quickly, a tagged port is simply one where traffic that has a VLAN tag on it can be routed to it. An untagged port is where it won't have that tag. So that's really the difference we're seeing. It's not, and excluded means it's not included one way or the other. You're not going to route traffic regardless to that port. So in this instance, you see we have VLAN 100, which is going to be on port 1, which is FE1, and it's untagged, meaning the devices, the Eclipse controller in this case, it doesn't know what a VLAN is. It doesn't have a VLAN tag. It has no idea. It just sits on the network and plugs into the port. So we have to, the switch has to take care of tagging that traffic with the correct VLAN on behalf of the Eclipse controller because it can't do it itself. So once it's tagged though, if we need to route it to another port, for instance, port 3 or port 4 in this case, we just mark those ports as tagged because once the traffic comes in from the ECY through the port, it picks up the VLAN tag and now it can route to any tagged ports. So it looks a little complicated when you first look at it, but it's important to note that that's how we're moving the traffic when we're taking a controller that doesn't know what a VLAN is and we're getting it into a switch, marking it with a tag, and then moving it around the network that way. And that's how we route traffic. And so here we show the VLAN. So we can select each VLAN and then select the appropriate tags for the ports that we want. Since a port can have multiple VLANs on it. And you see that here, port 3 and 4 have multiple VLANs tagged, but ports 1 and 2 are reserved strictly for VLAN 100 and VLAN 200 because that's where our devices are and they don't need any other VLANs. And so here you see our controllers, one on each VLAN, VLAN 200 and VLAN 100. And we're going to show here, we're going to look at whether those two controllers can currently talk to one another or not. And so we'll load them both through a web browser and we'll use a utility that's inherent to both controllers to test pinging to see if we can talk to each controller. So while we're waiting, and that's really the purpose of this is to isolate these controllers because if you have a network with thousands of controllers, if they have no reason to talk to each other, if a VAV on floor 1 has no reason to talk to VAV on floor 2, they should be isolated. So here we're going to try to ping these two controllers. I have too many IP addresses in my head, so. And here I'm in the second controller and I'm going to ping the first again. So once we have that, I'll attempt to ping it here. And you'll see there won't be a response. It won't come up with anything. because it doesn't have a path to that controller. It can't see it. And the same will be true for the opposite. If I go to the other controller, I won't be able to ping back and forth either. So what we'll do is we'll go to the firewall and we'll remove the rule that prevents these two controllers from talking. So we're going to allow the VLANs to talk to one another. And so I'll disable the rule on VLAN 100, and I'll also disable the rule on VLAN 200 so that we can now, those controllers can talk. And it won't just be ping, those controllers will be able to talk to each other on any port, since there'll be no rule preventing them from doing it. So we're going to demonstrate that here. So now when I go to ping that controller, I can hit it. And I could hit it on any port I needed to at this point, since I removed all restrictions. Although it's worth noting, you still will not be able to broadcast from one VLAN to another. That is blocked. So if you just want to hit port 443 or you just want to do a ping, that's fine, but you won't be able to broadcast. So if you're doing a backnet discover and you were sitting on VLAN 100, you would still only discover VLAN 100 devices. So here I'm enabling the rule again, and we're going to follow up and we're going to actually create a rule specific to ICMP, so we can just ping and nothing else. So here you can see once I enabled the rule, the controllers can no longer talk to each other. And we'll switch back to the firewall and we'll create a rule really quickly that allows these controllers to simply ping one another and nothing else. So here I'll select my protocol, and then I'll select my destination, which will be the other VLAN.
And just a note, the ICMP protocol is just for ping.
That's it. And there, we'll save those changes, and then when we go back to the controllers now, they'll actually be able to communicate, but they will only be able to ping one another. If I tried any other type of traffic, it would not route. And to the next one. So as you can see, VLANs are actually, once they're established, it's very easy to manage them with some simple rules. It's important to create the rules appropriate to the type of network traffic you need and not just open them up all the way, because that, in a way, that defeats the security of having the VLANs and the segregation. Because remember, people may be plugging into these VLANs for work purposes, and they also you may have laptops, you may have third-party devices that aren't associated, that are on your VLAN but weren't supplied by you. So you want to make sure the rules there are specific to the traffic you need and not just create VLANs and then open them up for everything, because it kind of defeats a lot of the purpose behind them, because we're really trying to segregate them from one another for a number of reasons. And when we later in other videos, when we go to create these VLANs and show you how to do that, we're going to cover that more in depth.
Yeah. Okay, so that was a bit of our routing with VLANs and firewalls mixed together to give you some very powerful routing tools within your network. So we talked briefly about a gateway. This is kind of the definition of what a gateway is. It's a type of router that basically allows you to access out to the internet and send packets that you don't know what the destination is. So very, very simple. Subnetting. Robert, I think this is
terrific. One of my favorite topics. So logical subdivision of an IP network. This is something that we, in most networks, whether it's at home or at work or for controls jobs, we typically abuse this and ignore this. We almost always use 255.255.255.0. Even if we only have 3 devices, we just give it the whole range because we don't want to. It seems like a lot of work to figure out what a correct subnet would be and then to assign it. And so, but that's problematic. We don't really want to leave it like that, because you end up with a lot of huge ranges on a building or a job where you could get by with a couple. and be far more efficient with the number of addresses assigned. And you may get to a job where a contractor or an IT department hands you a specific subnet, and it's important to understand what they're giving you when they give you something that says, 192.168.128/27, right? And we're going to show you an IP calculator that you can use to figure out what you need or what you've been given, so you know what addresses are safe for you to use. And most often, this will be something you're handed, because somebody may say, well, you have 3 controllers, and they're like, well, I'm going to give you a 240 subnet. So we can keep going forward with that. But subnets, unlike VLANs, subnets don't necessarily block broadcast traffic. So that there is a difference there. So on a small job or something like that, it's not the same as a VLAN, where VLANs have a better inherent security. So there's a lot more differences than that. But keep in mind, doing just a different subnet is not the same at all as doing a different VLAN. Subnets are a better way of just logically grouping stuff, not security. So that's important to understand. So we'll just say real quick, Class C, Class B, and Class A, this is really straightforward. This just refers to, most of you would look at it as like 255.255.255.0 would be Class C, right? 254 hosts. Class B is just 1 octet back, so 255.255.0.0, and then Class A would be 1 subnet back farther than that, or 1 octet back farther than that. So we'll go into the calculator, because this chart is not really the best for discussing it, but let's move on. So here's the calculator, and we're going to actually show you how to use this, but really quickly, you'll notice you can enter an IP address here, and you'll see many calculators like this, whether they're on the internet or you've downloaded some, but they work very similar. And what we do here is we define what we know or what we want. So in this case, I might give it my IP address, 192.168.0.20. And then I'll go down to the right there where it says hosts per subnet. And I say, well, how many controllers do I really need? Maybe I only have 15 or maybe 20. So I'll say 30 addresses should be more than enough. So I select host per subnet as 30, and then it fills in the rest of the data for me. It shows me that the hosts in that range that include my IP address are from .0.1 to .0.30. And the subnet ID and the broadcast address are reserved on either side of that. And you can't use those addresses. So you need to use addresses in the host address range. And those will be the ones you're free to assign in that subnet. And the subnet mask in this case, which it tells you is 255.255.255.224. You will need to put that subnet mask in every device in that range so that everything works. So we're going to go on to a demo and actually show you this, so it's much easier to see it once we're using it. So, all right. We'll start here the same way we have all of them. We'll go in and we'll discover our devices so we know what we're working with. So there's our IP address. For this demonstration, it's going to be 215.1, and our subnet is 248. So 255.255.255.248. And we'll kind of come back to that in just a second. So here we'll look at what controllers we're working with. So we'll discover them. And in case we haven't mentioned it before, this discover we're doing with this utility, that is always a broadcast. So we're doing a broadcast to discover that stuff. So if I wasn't on that subnet, or I mean, in this case, if I was on the network, I'm fine. But if I was on a separate VLAN, I wouldn't see them. So here we show the controllers both have a subnet of 248. And so here is the calculator we used before. And you'll see here, if I change the subnet mask to 0, you'll see I have the full range available to me there and there. But if I change the subnet to, say, 6 devices, you'll see that it automatically gives me the correct subnet mask and shows me the range of addresses I can use when assigning my controllers. So this is why we really recommend using a calculator like this, because it really simplifies the process and removes error for you. Because once you just put your IP address in, likely for your computer, and then fill in the number of hosts you want, and it'll give you the subnet. And you see here, since we're on the same subnet, 248, and the addresses that are assigned to the controllers are within those 6 addresses in my host range, we can talk. So we'll ping both ways. There we go. And so since we can talk, so now what we're going to do is we're going to use invalid entries, or we're going to move the controller, one of the controllers, outside of the subnet that it's currently in, so that you can see what happens when we either make a mistake or, in this case, intentionally do it wrong. So here I'm going to pick a new subnet, and I'm going to move a controller to that subnet. So I'm going to put what I want my IP address of my machine to be, which will be 9 in this case. And then it's going to give me 6 hosts, because that's what I want again. So I can use addresses between 9 and 14. So 215.9 and 215.14. I can use addresses in that range with that subnet. So I'll change this controller to be one of those addresses. And I'm going to change the gateway and the DNS to just be the IP address of my computer, just to simplify the process, since we're just really demonstrating this. And here, I'm going to add a second connection. And maybe we should talk a little bit further about this, Dave, while I'm about to do this. So what we're going to do here is we're going to add a second IP address to the same network adapter on my laptop. And this is something we do very commonly. This is a very good troubleshooting tool. And if you're working with multiple subnets, this is a very good way for you to test them and work with multiple subnets without having to remove yourself from one just to talk on another. So you'll see me here. I'm going to add a second IP and a second subnet mask to a single network adapter. And I'll show you how to do that right now. So go ahead and hit play if you don't mind. And here I'm going to add the second IP address here in a second. I'll show you. So here I just moved it simply first, and then I'll add it in a second to show you what happens. So let's talk to it and see what happens. And here I'm going to find the devices to make sure that I should only see the one on the subnet I'm on now. I can still discover the other one, but it won't show up as a valid connection. So I'm on the second subnet. And there I can see both, since that's a broadcast traffic, and we can broadcast across subnets, which you see there. I see both controllers, but I won't be able to ping the controller on the second subnet, which you'll see me try to do here. So let's log into the controller, and we'll attempt to ping the controllers from one another to show that we can't talk. So you see I can't load VAV2. So to do that, I'm going to have to add a second network address. And here, I'm going to add that second subnet. So now that I can work with both controllers, even though those controllers can't see one another, I'm adding myself to the first subnet we created, and I'm also on the second. So now I'll be able to communicate to both controllers. But the controllers won't be able to communicate directly with one another. And if this was a supervisor, if you needed separate subnets, this would be a good way to manage a supervisor, just to have it sit on both subnets. If you needed it to talk, say, to both controllers over BACnet, this would be a good way to handle that. BACnet IP anyway. Okay, you can see here I can ping the first subnet, and I can ping the second subnet. And now we're going to show that the controllers won't be able to ping one another. Okay, so now the next step, since these aren't going to be able to talk, and let's say these are the addresses these controllers need to have, and perhaps my subnet is too small. Maybe I need to expand my subnet. So we're going to show you how to do that as the last step is how do I expand that subnet to encompass the controllers so that they can then talk. Because perhaps these are addresses that were given to me and I maybe created a subnet that was too small. So I'm going to increase the number of hosts. So I'm going to put the address of my laptop, and then I'm going to increase the number of hosts to 14. And you'll see that range encompasses both controllers. And that's my new subnet is 240. So 255.255.255.240. And so I'll leave the addresses the same, but I'll change the subnet and I'll make sure my gateway and DNS are updated to reflect the new settings. In this case, like I said, they'll just point to my laptop because we're testing directly. There we go. There we go. And so now that the subnet's changed, I'll change the subnet on my laptop and I'll get rid of the second one and I'll just expand the first one so that I can use both. There we go. And I'll change my address to 1. And now all the controllers will be able to talk to one another and I'll be able to talk to both on a single subnet. So really what we're trying to showcase here is that you should be using, when you're doing a job, you really should be using a subnet that's reasonably sized for the number of controllers you have. If you have 300 controllers, and you want them on a single subnet, then you should use the calculator and put 300 hosts in there and figure out what an appropriate subnet would be for 300 controllers. Also, if you have 6 controllers, you might leave yourself a little breathing room and say, okay, I'll have a subnet with 30 or a subnet with 14, but it doesn't make sense to have a subnet of 255.255.0.0 with thousands of potential addresses for 7 controllers, right? That's just, and also it's not necessarily from a security standpoint, but from a logical grouping standpoint, it makes sense to group these together so that if somebody were to come along and put a laptop on the network or add another device, you don't end up with overlapping ranges. The tighter you make your range, the less likely anybody's going to interfere with it, or you'll have conflicts on your network. And so it's better to use it. So you can use subnetting. You can combine subnetting with VLANs to have a really nice network that's logically divided within VLANs, and also using VLANs for the security they offer you. So you can use these in combination to have to really divide your job up instead of just doing it like most of us do architecturally and just saying, oh, I want a VLAN per floor or a subnet per floor. You can divide much deeper in, or you can expand out, but you can use these things for what they're intended, and that's really where we're focusing. VLANs are really, to isolate traffic, and subnets are just to group devices. That's the best way to think about it. It can get more advanced than that, but from where we sit here, that's really how you should think about them.
Okay, so from Robert's favorite topics to one of mine. So NAT, which stands for Network Address Translation. We talked briefly about the private IP addresses and how they were reserved, and now we'll talk about why and what they would be used for. So basically, from the what point of view, any router or gateway with a NAT capability can allow assignment of the private IP addresses inside of its network. So what you see here is a bunch of devices on the left. They're all within the 192.168 subnet. So those are private IP addresses. They're not routable out onto the internet. However, what we've done on the NAT service on the router is we've created a mapping between those private IP addresses and a single internet routable IP address. In this case, 206.12.0.1. So that's what everything within this network appears to be when it sends packets out to the internet itself. And so that gives us a couple of benefits. So number one, there's a security aspect to it. Number two, it conserves IP addresses. I'll talk a little bit more about that on the next slide. Now, the way it does this is it uses port mapping. So you can see the examples down on the very bottom of the slide. So, for example, I have a web server that I want to maybe be exposed to the internet, and I've got it mapped onto port 2, 3, 4, 5, 6. So within the setup of your NAT, you basically just add a row to the table that says map this IP address to this port on the public IP address. And then whenever traffic goes through that router, it will basically convert that and change it. And also on the way back as well. So if anything's on the way back and is destination is 206.12.0.100 and port 23456, it knows to send that to a specific destination. So that was the what. The question is the why. So why do we do this? And there's two big reasons. So number one, we're running into issues right now in terms of IP addresses. 50 years ago, when they started building IP addresses, signing them out, they figured 4.3 billion was quite enough. And there wasn't that many people on the earth at the time, I don't think. So they didn't expect it to ever be exceeded. However, we have way more than that now. You know, that with Internet of Things, people having multiple devices talking to each other, there are now billions and billions of devices on the internet that all need some form of IP routing. So to conserve IP addresses, we're going to use natting, and then within the private IPs, we can use that private range over and over again within different private networks. But they all appear publicly to have to be mapped to the port using the NAT protocol. So in the OT industry, we're growing into this right now, and we're a big piece of increasing those numbers. And probably, you know, as you go into projects, you'll have more devices than you will assigned IP addresses. You're going to have to use NAT at some point if that's the case. And then the second reason is the added security. And this isn't true cybersecurity. It's not going to stop somebody from hacking. But what it does is it protects the address that's actually assigned to your device. Nobody outside of the network knows what that is. So they can't send direct message to it unless they do some sort of port scanning and try to hack in, and you'll be able to detect that at your router. So it creates a single point of security on the router, and you'll be able to detect hacking patterns. So it adds that layer of security. It doesn't necessarily add security in terms of data encryption and that sort of thing, but it gives you an idea of when people are trying to access your internal network, and it protects the IP addresses from being visible. We're getting low on time here, so generally speaking, NAT is a feature of a router/gateway, and there's really no other place to put it. So most routers that you buy will have this built in. It's been around for a long time, and it's kind of a basic feature of it. All right, DNS. Back to you, Robert.
All right, we'll kind of speed this one along since we're getting short on time. We'll just cover this briefly. DNS is the domain name system, and we covered it a little bit earlier in the presentation, but you'll usually run these, either they'll be assigned to you by your company or your ISP or your IT department, or if you're assigning them yourself, you'll simply use something you may have heard, like on the next slide. You'll see something like Google's 8.8.8.8 and 8.8.4.4 and then Quad 9 and OpenDNS. And really what these companies are doing, they're just providing a service that resolves a host name to an IP. They have, you can, when you're deciding who you want to use, if you do get a choice, they all have various reasons and why they provide these, but some of the major providers we've listed here are very safe. So Google, Quad9, and OpenDNS, they're fine. I'm sure, as all of you are aware, Google knows everything anyway, so what does it matter if they know your web address? But generally speaking, this is where you'll put these entries in. Now, some ISPs and some companies will block this traffic and force you to use their DNS server. So if these don't work, you may be forced to use the DNS server the company provides you, and that's worth asking about in case you typically default to using something like this. You need to make sure that the IT department allows for that, and that's why we mention it here. And other than that, I will mention, if you are doing any type of host resolution internal to a network, you will definitely need to use that network's DNS server. You can't use Google and expect an internal host name to resolve, right? So you have to, in those cases, so most of the time it's advised, if you're doing work for a company or you're on a managed system, it's really advised that you use their DNS server, a local one that he shows here on this slide that's provided. But if you're setting up the job yourself and you're handling everything and you just have a modem from another provider maybe, then you're free to do it how you'd like. But even then, you're probably going to want to give all your devices the DNS, the address of your router for DNS, and allow your router to route out to Google or Quad9. So very rarely would you be putting those addresses we listed before. Would you want to put those in the controller? Most of the time they will be in the router or at another level, and you would just use the local, like you normally see. Your gateway and your DNS will frequently be the same on a network. That's very common. So just keep that in mind. But most of the time a company will give them to you, and if they do, it's usually recommended you use them.
Okay, and we'll briefly talk about Firewall and VPN. You saw in the demo setting up some firewall rules, and basically all they do is permit or block traffic. So each rule might say a specific service or a specific port, can have ingress or egress traffic blocked or allowed. And this is a very blunt tool. So if you need a hammer, this is the hammer. And the problem with it obviously is if you're opening up, for example, port 47808, anybody can get through that port. It's not very intelligent in terms of that. Whereas if you created a VPN or if you had VLANs, those things provide a much more focused security on it. And so for VPNs, what I will note is that in our big demo that we're going to do in the future, in that webinar, we're going to go into some detail on how to set that up and how to actually access the network via VPN. It's pretty straightforward, but we've been asked at a previous one, and we don't have time to talk about that today in great detail, but we'll do that in the next one. The key about the VPN is it gives you a point-to-point connection, and that whatever the client is appears to be part of the internal network, and it's just that device has access. So you're not actually opening up to the public. You're being very specific on who has access to what. So it's this is a much more refined tool as opposed to the firewall, which was a more blunt instrument. So yeah, we'll show you some on how to do that. Where these things sit. So if I'm a VPN client out on the internet, I'll have a tunnel built in through the system and out to the VPN server, and that'll allow me to have access. Whereas if I'm a firewall, I'm either integrated with the router gateway, or you can have a standalone firewall, and because it's just a filter, you can put it within your network to block traffic after or before the router.
And it's worth just noting here that between the two, making firewall rules to allow for access to your system or setting up a VPN server to allow access to your system, the VPN server is far more secure. And once it's set up, it's far easier to support, because you're on your network, you can see your devices, and you don't have to have funny rules for port forwarding or external access and these things. So between the two, you're going to need both, but the VPN server is going to be your preferred method to access a network outside of the company, or in some cases, it's even the way internal to companies that they access specific VLANs, that they make you VPN into that VLAN. So VPN servers are a topic that can get pretty big, and we will cover it, but it's worth noting that in a general sense, it's almost always preferred to just opening up ports on a firewall. So there's very few scenarios where the reverse would be true. So if you're given the choice to use VPN or provide it, you can always call and ask myself or Dave or call our companies and inquire, and we can give you a lot of detailed information. But as a general rule, VPN is where you want to be. So.
All right.
Great. Well, thanks so much, you guys. We have a lot of questions. There's one or two that I want to touch on quickly. For those of you who don't get to your question, we will follow up with you individually. Robert and Dave, we had someone here asking, it seems that reserving an IP address in the DHCP server is essentially the same as giving it a static IP address. So can you speak a little bit to that, and what's the benefit of doing it on the DHCP?
It is very much the same thing until you want to change it, and that's where the difference comes in. So if I'm assigning, it's the same amount of work initially to do both. So if I have 1,000 devices and I want to give them all an IP address, whether I log into each controller and I assign an IP, or I log into the firewall and I copy the MAC address and I paste it in, yeah, that's a lot of work initially. The benefit with a reserved lease and DHCP is now whenever I want to change any IP on any device, on any number of devices, now I can do it one time very quickly in a few minutes. If you did everything static and then you decided you needed to change it, you'd have to go back and do the same amount of work over again that you did the initial time. So DHCP with reserved leases, it is the same amount of work. There's no changing that, but it's one-time work. You won't have to do it ever again. So that's, and in some routers, actually, some systems even allow you to import CSV tables that have the MAC addresses in there. So there are ways to speed that up. But generally speaking, if you're just doing it manually, it is the same amount of work. But it's like I said, with DHCP, it's once, and then you can later on you can say I made a mistake, or I want to have VLANs, or I want to do this, and you can just go in there and you change a bunch of IP addresses, and the next time those leases update. So a lot of times, typically, what a company does is they're going to change IPs. At the end of the day, they update the DHCP server, or at the beginning of the weekend, they update the DHCP server, and then when they come back on Monday, everything has the IP they want, and they're ready to go. So it's much better. So that's why we prefer it on big systems. I will grant you, if you're just doing 7 controllers, it's irrelevant at that point. It's up to you at that point. There's no, at a low number of controllers, it's more your comfort level then. I still use it at a low number of controllers, simply because I'm lazy and I change IPs a lot and I don't want to have to go log in every time we do it. So it's up to you.
You never know if you're going to have to change them, so you might as well save yourself that time. Okay, one last question. If any of you do have to leave, please fill out the survey that's going to pop up when you close the webinar, because we really want your feedback. We are doing more of these. But the last question I want to leave with is, BACnet IP panels don't resolve by name, correct? That's the question. Is DNS something that's needed for BACnet IP devices? There's a lot of people out here BACnet IP.
No, right now, if you're doing a BACnet job, for right now, with the way things are typically in the industry, you're probably gonna just ignore host names. You're gonna need to use IP addresses and specifically. So it would be nice if we could use host names with BACnet. That would be fantastic, but right now, and in a lot of systems with BACnet, there's still a lot of legacy stuff down there. So even if they released it today and they allowed for us to do that, it would take a long time for adoption to take place. So generally speaking, if you're doing a job and it's BACnet IP, you want to stick with identifying the devices by IP address. But it is perfectly fine, though, if the devices have graphics and things that the customer needs to access. By all means, the host names are perfect for that. So it's just for BACnet communication, you should not be using host names. But for any other type of communication, it's typically fine, especially if it's if you're doing, say, to one of our controllers, you're doing like a REST command, or you want to access the graphic, then a host name is perfectly fine. So but speaking specifically to BACnet, no, it's likely you're not going to be able to leverage it.
Okay, great. Thank you so much, you guys. Again, we will get back to some of those questions. Please fill out our survey, and please join us on the next 2 webinars. We'll be covering all kinds of good stuff, and especially in that last one, we'll be diving into actually putting all of this into practice and setting up a network. Thanks again. Have a great rest of your day, and please reach out with any questions. Dave and Robert, thanks so much.
Bye.
Thanks, everyone.